Question number 2 says to get a resultant displacement of 10 meter, two displacement vectors, one of magnitude 6 meter, another of 8 meter should be combined at what angle? Now how do I find out the angle between them? One is a very straightforward answer. Straightforward answer says it's a 6 meter and a 8 meter, and I know 6, 8 and 10 are Pythagorean triplets, so it must be 90 degrees. The angle between them must be a 90 degree. They must be perpendicular to each other. That's a very simplistic answer, and that's nothing wrong about that. But let me go into a more generic method of solving such questions. Let's say I have two vectors A and B, and angle between them is theta. Now how do I find out the resultant of these two vectors? Now let's try to break down. Let's say your x-axis is along A and your y-axis is obviously perpendicular to that. What I'll do is I can find out two components of B, one along the x-axis, which will be equal to B cos theta, and one along y-axis, which will be equal to B sin theta. So your resultant, the x component of your resultant will be equal to A plus B cos theta, and the y component of your resultant will be equal to B sin theta. And how do I find out what will be the magnitude of resultant? So resultant will be under root of Rx square plus Ry square, or you can just say R square is equal to A plus B cos theta whole square plus B sin theta whole square. Now let's try to find out the values of this. So this will become R square is equal to A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Fair enough? Can I combine these two? I can take out B square common, and cos square theta plus sin square theta will become 1. So I can combine these two terms and just say B square. So the resultant, the square of the magnitude of the resultant will be equal to A square plus B square plus 2AB cos theta. Fair enough? And what will be the angle which the resultant make with the x-axis? The angle which resultant makes with an x-axis, let's call it phi, will be equal to tan inverse of Ry upon Rx. And why do I say that? See, this is your Rx, this is your Ry, and this is your R. So the angle which it makes with the x-axis phi, tan of phi will be equal to Ry upon Rx. So tan inverse of what is Ry? Ry was B sin theta upon A plus B cos theta. In this question we did not need to find the angle that the resultant made with this. Our answer could have been gotten from using this. Let's try to use this and see. I said the square of the resultant must be equal to A square plus B square plus 2AB cos theta. Obviously A and B are the magnitudes. In this case it's given the 10 square must be equal to 6 square plus 8 square plus 2 into 6 into 8 cos theta. Clearly 10 square, 6 square and 8 square will cancel each other, which means that cos of theta must be equal to 0 or theta must be equal to 90 degree. Fair enough? That's the solution for question number 2. Now for the third question that you have asked me is, a person moves 30 meters north. Let's say your north is along this direction. Obviously then east will be here, west will be here, and south will be somewhere here. It says it goes 30 meters towards north, 20 meters towards east, 20 meters towards east, and 30 root 2 meters in the southwest direction. So the southwest direction means that it will make an angle of 45 degree with either south or west. Now since I've taken, this is already along x-axis 20 meters, 30 meters is along y-axis. I can break it down. This will become 30 meters towards south, and this will become 30 meters towards west. Why did it become? Because the x component of this vector, let's call it c, the x component of this vector c will be equal to 30 root 2 sine 45. See, I've taken this angle to be 45 degree. So along x-axis it will be sine theta, and sine 45 is equal to 1 by root 2, and hence it becomes equal to 30. Similarly, along y-axis also it will be 30. Now what you see is that this north component cancels the south component. So the displacement along north or south is 0, and effectively the object has moved just 10 meters towards west. Object has moved effectively 10 meters towards west. To solve such question, put all your vectors on an xy axis, find the components along x and y, and do a simple calculation along one dimension for both of them. Answer will be a breeze. Make sense? Don't try to go it like this, it went 30 meters north and then 20 east and something like that. It's very difficult to get the points here. It's easier if you plot them on a graph. I'll do that again for you. Let's plot the graph. How do I plot the graph? You make your x and y axis. Take north and south as y axis and east and west as the x axis. And what do you have now? 30 meters towards north. You had 20 meters towards east. And you had 30 root 2 meters towards southwest. That's the beauty of vectors. This is east, west, south and north. Now you know what all directions you went into. Find out the components and see how much is the total displacement along x and what is the total displacement along y, and then you can find out your final position.